My name is Manmeet Walia and I'm the Marketing Manager for the HDMI IP product portfolio at Synopsys. Today I will show you a demo of the silicon-proven DesignWare HDMI transmitter, controller and PHY IP using the Synopsys HAPS-51 prototyping platform. The HAPS-51 prototyping platform is a general-purpose development and prototyping solution. You can see here that there are 6 general-purpose HAPS-2 connectors on this HAPS-51 board. They can be configured for the custom usage and for the standard IP interfaces. For today's demo, we are going to use just one of the connectors to interface to our HDMI TX test chip. This particular test chip was fabricated in the chartered 65 LPE process. As a leading provider of the HDMI IP, Synopsys has ported its TX and RX PHY IP in over 10 process technologies from major foundries. We have placed our chartered 65 LPE TX PHY test chip on a HAPS-2 daughter board to interface to the controller that is mapped into the Xilinx Vertex 5 FPGA. Other than the HDMI TX controller, the video and audio pattern generators are also implemented in the Xilinx Vertex 5 FPGA that can be seen under the fan here on the HAPS-51 platform. The HDMI TX controller is currently running at a 225 MHz pixel clock. The Synopsys cores can support up to 340 MHz pixel clock or an aggregate bandwidth of 10.2 gigabits per second to support the latest 3D formats, 4K resolution, and other common formats such as 720p or 1080i/p at 120 Hz frame rate. To begin the demo, we reset the HAPS board and wait for all green lights. The motherboard is connected to a laptop via USB cable, which can be seen here. Initialization and control of the HAPS-51 board and configuration of the TX controller is done through this USB connection. An on-board USB to I2C converter is used to interface with the I2C HDMI TX controller interface. The output video pattern from the FPGA is sent through the PHY test chip to this HDMI connector on the daughter board out to the display. The first step of the demo is to read the EDID block from the display. Extended Display Identification Data, or EDID, is a data structure provided by the display to describe its capability to the source card. Synopsys has developed HDMI API software running on the laptop that allows you to control and debug HDMI systems. So first we will read the EDID information contained in the TV's EDID ROM using the I2C Display Data Channel hardware implemented in the HDMI TX controller. So here is the EDID text file, and it shows the various formats, color depths, horizontal and vertical blanking parameters, etc. that this display can support. The HDMI spec calls for a negotiation between the source and a sink to find a commonly supported transfer resolution and frame rate. The EDID read utility on the laptop allows me to read the complete capability information of any HDMI sink. The next step is to select a resolution and frame rate supported by the display. We will start with 480p 60 Hz frame rate. I have started a script on the laptop to configure the IP and transmit this test pattern. The DesignWare HDMI TX controller combines the video, audio, and data info frame packets of HDMI compliant frames. The TV automatically detects the audio and video mode sent by the HDMI TX controller and extracts the audio and video frame packets embedded in the HDMI frame. While the test pattern is loading on the display, I will expand upon the test pattern generator capabilities. As I explained earlier, there is a video and audio pattern generator inside the FPGA. The video pattern generator is capable of transmitting any video mode described in the CEA 861D spec, which has a total of 59 video modes and a pixel color depth of 8, 10, 12, or 16 bits. The audio pattern is capable of sending two audio tones in linear PCM format, one for the left and one for the right audio channel at sample rates from 32 kHz up to 192 kHz through the I2S audio channel or through SPDIF channel. The IP is also capable of sending a fixed high bit rate audio pattern data. The configuration flexibility of both audio and video generators make the HAPS-51 demo platform ideal for development, testing, and compliance purposes, enabling the configuration of any test scenario used during compliance testing. The HAPS-51 is Synopsys' platform of choice at HDCP Plugfest events and also to get our IP certified by HDMI authorized testing centers. As you can see, the script has completed and the 480p test pattern is displayed. The tone you are hearing is an audio test tone we have included in the HDMI frame. The audio modes can be varied to test all possible audio modes supported by the HDMI sync. To conserve time, I have loaded the 720p test pattern, and in a moment I will display the higher resolution of 1080p test pattern. We will keep the test image at the same number of pixels, and therefore it will be repeated approximately 4 times as you saw in the 480p mode. I'm going to run the 1080p script on my laptop now. While the 1080p pattern is loading, I want to explain that the fixed size image pattern that is stored in the Vertex 5 FPGA is repeatedly sent over to the display over HDMI. For lower resolution mode like the 480p, the same pattern fills larger portion of the screen, while for higher resolution mode like 1080p, the same pattern fills only a small portion of the screen, hence you see the pattern being repeated more often. The configuration is complete and the test pattern is being transmitted and displayed in full 1080p 60 Hz video mode with the same audio tone as you heard before in 480p mode. 1080p 60 Hz means 1920 by 1080 pixels transmitted at 60 full frames per second, scanned progressively. Note that most Blu-ray content available today is encoded at 1080p 24 frames per second, while the most common HD channels are only 720p or 1080i modes. This demo achieved an information transfer rate that is much higher than the rate of the commonly available high-def content. To summarize, Synopsys provides complete HDMI 1.4 compliant source and sync solutions. Synopsys is a leading provider of HDMI IP and is currently engaged with major consumer electronic companies, OEMs, ODMs, and foundries worldwide. For more information about Synopsys HDMI IP, please go to our website at synopsys.com/HDMI, and thank you for watching.